All right, so you'll find on the website, mrmathwell.com, under your Foundations of Math 20 page, here is a Chapter 4 homework. 4.4, we're going to take a look at number 2. Number 11 is also on here. If you have trouble with number 11, please watch that video. I'll help you do that. So right now we're recording number 2. So number 2, two forest fires, A and B, are 20.3 kilometers apart. So they give you the diagrams. You do not have to generate your own diagram here, so that's great. Here's Tower A, here's Tower B, 20.3 kilometers. From Tower A, the compass heading for Tower B, that is how to get to Tower B from Tower A, is south 80 degrees east. So if this is north, that means this is south down here. So if we go 80 degrees east, this is where 80 is. Okay, so that's south, and then you head towards the east. Remember, it's north, east, south, west. Never eat shredded wheat. Okay, although I like shredded wheat, that's just a memory thing that from when I was in elementary school. So never eat shredded wheat. So south, and you go 80 degrees east. All right, the ranger in each tower sees the same forest fire. Here's the same forest fire. The heading of the fire from Tower A, again, is north 50 degrees east. So we have that labeled here, north 50 degrees east. Start on the north and again travel towards the east 50 degrees. The heading of the fire from Tower B, so over here, is north 60 degrees west. So it's north and then you travel towards the west. Okay, so that's 60. So that's on your diagram there. Okay, awesome. How far to the nearest tenth of a kilometer is the fire from each tower? So I'm looking for this. We'll call this little b, and I'm looking for this. We'll call this little a. So how far is it from each tower? Okay. So what can you determine that is unknown right now? But what can you figure out pretty easily from this diagram? Anybody see anything, Josh? Okay, so the Tower A angle, or the angle between the fire and Tower B here, right? So how do you find that, and what is it?
180 minus 80 minus 50.
Perfect. 180 minus 80 minus 50, which gives us 50 degrees. Very good. Okay, so that's great. We know that this is 50 as well. Okay. Anything else?
It's an obtuse triangle.
Okay. How do you know it's an obtuse triangle? How do you know this is an obtuse triangle? Just by looking at it?
No,
Kind of.
the line is 20.
Also noting that the angle B by Tower B is,
This one here?
yeah.
Okay. Do we know what this, can we figure out what this angle is right here?
Yeah.
Okay. How do I figure this out? Now, okay, first of all, you said this is an obtuse triangle. It looks like an obtuse triangle. This looks pretty close to 50, so this looks pretty close to 60, so this looks like it's pretty close to being to scale. So if you look at that, it looks more than 90, right? But yeah, we're going to be able to find that out for sure in a few seconds. But let's work on this over here. Is there any way we can tell what the angles are over here?
No, we don't need.
Hey, hand up.
Is it because 80, well, 180 minus 80, and then,
What's 180 minus 80?
They're parallel lines.
yeah, they're parallel lines.
Okay, so these are parallel lines. Very good. What just happened there? Okay, so yeah, that's a parallel line with this one. Good. So what does that mean? Go ahead, keep talking.
180 minus 80 is the other side of between
Oh, I see. I see. So you're treating this as a transversal here.
Yeah.
Ah, beautiful. Okay, and so you're saying to me 180 minus 80, is that this angle over here then?
Yes.
Okay, so these two have to be supplementary. Good. So this is a angle of 100. Does that make sense? Is that what you're saying? Awesome. Okay. All right. So is there anything else we can figure out now? And specifically with regards to this triangle.
Angle B is
So this angle in here then is 100 plus 60 is 160. 180 minus 160 is 20. Awesome. Okay, so this is perfect. That's excellent. Another way you could have done this is, again, viewing these parallel lines. This is a transversal here, and this 80 is also 80 over here, right? 80 here, is 80 over here, alternate interior. So 60 plus what is 80? You get the 20 that way as well. Okay, awesome. Okay, now what can I do here? Can I use a sine law, or can I use a cosine law, or can I use primary trig functions? Is there a 90-degree angle here, or what are your thoughts here now? Sine law? Can you use a sine law?
You can use, wait, but you have.
You can use the sine law.
Can you? Okay. Do I have an angle and an opposite side pair that I can use?
You can find the one for fire.
You can find angle phi.
Very good. Yes, you can find this one because now we're given 2 angles out of 3. So I can find this one. So 180 minus 70 is 110. Good job. Okay, so I can find that angle as well. And now I have an angle and opposite side pair. So I can probably use the sine law, which is absolutely correct. Then I can find, let's say A or B here, because I have this angle. So I love it. Sine law. Let's use sine law. So I'm going to set up, I'm trying to find the side. So I'm going to put the side on top. So 20.3 over sine of 110. Okay, that's the pair that I'm given. Equals, let's find the B here. So B over sine of 20. Everyone see that? Now I bring sine of 20 over here, and I get rid of it from down there. And so on our calculator, let's do that real quick. So sine of 20, let's turn that on. Let's clear that. Sine of 20 times 20.3. I usually hit an equals when I do the numerator, and then I'll go divided by whatever's down the bottom there now. I split up in a couple operations. You don't have to, but that's what I do a lot of times. Just because you don't have to use brackets and it'll get mixed up and stuff. But so divided by sine of 110, make sure you're in degrees. So I get 7.38859. Does anybody else get that? Anyone else confirmed? Yeah, I'm seeing some nods. Awesome. So B is 7. Let's keep all the decimal places for now. 7.3886, or a bunch of them anyways. B, 7.3886. Okay, so that's going to be kilometers. Okay, from tower A to the fire. Awesome. And then we do the same thing for little a, and so 20.3 over sine of 110 equals, let's do little a now, over sine of 50. So we'll do sine of 50 over here. Okay. So on our calculator, let's try this again. So, sine of 50 times 20.3 divided by sine of 110. 16.5487. Anybody else get that?
Yep.
Good. 5487. Or so. So now that's what we're trying to find, right? That's it. Okay. So now let's round it to the nearest tenth of a kilometer and state our answers clearly. So from distance from tower A to fire is actually little b there. So is 7 to the nearest tenth, 4 kilometers. And distance from tower B to fire is 16.5 kilometers. Write that out, kind of a word sentence for a word problem. Please identify, circle your answers there. I still like all the answers being circled, so please make sure you do that. And can someone check the back of the book there? Does that line up with the solution key that you guys have there for number 2? Yeah, go ahead and check. All right, so go ahead and continue on with the rest of your assignment here. If you're in my class right here, 2, 3, 6, and 11. And yeah, number 11, if you have trouble with number 11, there's a video on number 11 as well on the website.
Mr. Maxwell?
Give me a second.